Oh, I clicked the wrong thing. What is wrong with me? Brian, don't worry if you miss this, you won't have any problem with it. Okay, so keep writing your quiz. Okay. All right, my friends. Just in case you get to page 65 and you're like, what on earth is going on? What are these numbers? What are we doing? If you already know what you're doing, just keep working ahead, okay? You're good to go. So, you will always have access, whoops, supposed to be a highlighter. You will always have access to a periodic table in tests, exams, quizzes, whatever, so you don't need to memorize things. But being familiar with the symbols can be very, very helpful. So, what we're going to do is we're going to take a look. We're going to take a look at the element name, aluminum. And probably for you, one of the easiest ways to find aluminum, you could go looking on the periodic table if you know your periodic table. And you could say, oh, look, I found aluminum, it's Al. But if you don't know your periodic table very well just yet, you might have trouble finding it. So you can always flip to the back of the periodic table because it's all nicely in alphabetical order for you. So you can look up aluminum and find out it is Al. Now I want you to take notice of this. What do you notice about the first letter? What kind of letter is it? It's a capital. And the second letter is a lowercase. So it's always going to be the case that if there is more than one letter, the first one will be a capital, the second one will be lowercase. So we would then go here, and we would say we have aluminum, Al. Now what the heck is going on with all this stuff over here? So this is made up of the first letter, so I'm going to write 1, but it's also made up of the first letter plus the second letter. So I'm going to write 1, 2. Now why did I choose a dot? I don't know. I could have written 1, 2. I could have written 1 dash 2. I don't know why I chose a dot. It just means the first letter and the second letter. Does that make sense? Okay. Let's go look up the second one now. Let's look up antimony. Antimony. Whoa, what the heck is up with antimony? Antimony contains letters A-N-T-I-M-O-N-Y, and its abbreviation is SB. That has nothing to do with the word antimony. How can that be? Yes. Yeah, when you see something that is that far separated from the actual name, you know it came from another language. So back on our worksheet, you can say antimony is SB, and it came from another language, and you can just write L for different language. There's a couple others that I wanted to point out to you, just to give you an example. One of them is chromium, or no, cadmium. Cadmium. Let's go look up cadmium. Scroll down till you get to the C's. Cadmium is not Ca. right? Because Ca is already taken. Calcium is Ca. So we have to use the third letter of cadmium. So we have the first letter and the third letter. So guess what we're going to write when we go here? We're going to write our first letter and our third letter, 1.3. And finally, carbon. Carbon's just a C, there's nothing else. Has to be a capital letter, and so we would just write 1 because it's just the first letter. Okay, so that's how all of those work. I would like to give you guys about 10 minutes to continue working on that, and then we're going to go over some periodic table stuff together, okay? The rest of what you don't finish of this will be homework. All right? Why are you not pausing, you stupid recording thing? Okay, my friends, I just wanted to draw your attention to a couple of things. First one is, when we get to sulfur, two different ways. It can be spelled with an F, or sulfur can be spelled with a PH. Now, I'm going to let you know, most of my resources say PH because for years and years, the periodic table that you have, for example, was a BC government resource, okay? So I was like, okay, let's just go with that. So I've made all of my resources say PH. And then the official people, the International Union of Physicists and Chemists, IUPAC, said it's officially an F. So all my resources are now wrong, but I don't care. If I had another 10 years left in my career, I would probably be like, okay, I'll go through and change them little by little. But I'm looking more like 3 to 5 years. I want to be out of here because there's just some weird, wacky stuff that's happening in the education system that just doesn't sit right with me. And so I'm not going to change it. So just be aware, sulfur can either be an F or it can be a pH. You're correct no matter which one you use, okay? The other thing I wanted to point out is if you do use the answer key for this, which I think most of you are not doing, which is probably an okay thing because I don't know how I managed to do this. For copper, I wrote CO. It's not CO, what is it? Cu. And for manganese, so copper should be Cu. Manganese, I wrote Mg, but I also wrote Mg here. It's correct here. It's not correct here. What is manganese? Mn. So just so you know, my answer key had a couple of boo-boos in it, okay? And now, what we've all been waiting for, the intro to the periodic table. Periods. Periods go this way. They are the rows. How many rows do we have on the periodic table? There are 7 of them. So if we zoom in a little bit, we can even write, this is period number 1. This is period number 2. How many elements are in period number 1? There's actually, if you go all the way across, I'm just going to highlight all the way across. Shoo! Whoa, how many elements in period number 1? 2 of them. Okay, they're on opposite sides. And period number 2 has 1, 2, 3, 4, 5, 6, 7, 8. Okay. And period 3 has, again, 8. And then we all go all the way down to period number 7. Those are our rows, they go side to side. A group, on the other hand, groups go which direction? They go up and down. They are vertical. Groups are also known as columns. Well, they're not also known as columns. The columns are called groups. Are you guys familiar with the term column in terms of like a building? You know, like if you look at the Greek buildings, it's got the big pillars. Those are the columns. They go up and down, right? So this here is group 1. This is group 2. And then we go all the way over to the far right where we get to group 18. So there's a lot more groups than there are periods. So the periodic table is organized into what? Periods and groups. Periods are the horizontal rows, whereas groups are the columns that go up and down. And it tells you something that you probably don't understand yet. Elements in the same group have the same number of valence electrons. You don't know what this is yet, but I'm going to tell you just so you have a little note of it, so you've introduced to the idea. This is the number of, this is the electrons on the outermost shell. That's what valence electrons are. Okie dokie. Now we're going to skip this. I'm going to let you guys do those questions. And we're going to go on to page 69. Metals. I'm going to show you an example of a metal because I recently learned that approximately 1 in 10 people cannot visualize things in their brain. It's because their brain works differently. So if you see pictures in your brain, not everybody does. And did you know that not everybody has a running dialogue in their brain? Like they don't hear the words and stuff. Some people don't, like, you know, when you're thinking something, when you're running through some old conversation in your head where you're like, oh gosh, I shouldn't have said that, and you can hear your words. Some people don't have an inner dialogue. They think in ideas rather than words. And some people cannot see pictures in their brain. So I'm going to be I'm going to try and be more cognizant of that. I'm going to try and be more, remember that more. And I'm going to tell you that you're going to look at this metal and you're going to tell me, what does it look like? It's shiny. All metals are shiny unless they've got like an oxide layer on them, okay? They are shiny. They are hard. Why do we make our pots and pans out of metal? Because usually our pots and pans, they're like steel or aluminum. They conduct heat, which means if you put your pan on the stove and you've got your food in there, the heat from the element takes very little time to pass through the metal and get to your food. If you had a pan that was made of glass, which is a non-metal, made of non-metals, it would take a long time for the heat to get to your food. It would still cook, but it would take a long, long time for the pan to heat up. Okay, because non-metals are poor conductors of heat. So, metals conduct heat and they conduct electricity. Think about electricity in your home. How does it get there? Wires. What are wires made of? Copper, usually. Okay, so they're made of metal. You could actually make your wires out of gold, but that would be very expensive. And gold is very soft metal, so it might tend to break more easily. All right, let's do some labeling here. Over on the far right of the periodic table, we have the nonmetals. Over on the left of the periodic table, this is page 69. Over on over on the left, we have the metals. In between the metals and the nonmetals, we have these things called metalloids. Okay? And they have some of the properties of metals. They tend to be shiny-ish, but not as shiny as metals. They also tend to conduct, but not as well as metals. And when they bond with other elements, they bond like nonmetals. So they do some things like metals, they do some things like nonmetals, and those are called the metalloids. Now there should be one little element that is sticking out like a sore thumb here. Which element looks like it doesn't belong where it is? The one at the top left, right? Hydrogen. Hydrogen, even though it's on the left and it's sort of slotted in with all the metals, it's actually a nonmetal. So you just have to remember hydrogen is placed kind of funny. We'll talk about why that is a little bit later in the course, but not right now, okay? So you have your metals, you have your metalloids, and you have your nonmetals. And, oh look, what's down here? What kind are these? These are also metals. And I'm going to skip number 2. I'll let you do those yourself. And now we are on page 70. If you are ever looking for things, and you're like, I don't know what the groups are called, I don't remember, I'm just going to let you know in your data pages on page 4, you have a labeled periodic table that gives you all the names of the groups, tells you where the metals are, where the nonmetals are. All the names are on there just for your reference. This is page 4, okay? But you don't have to use that right now because I'm going to tell you, all right? Some of the groups, which way do groups go? Tell your partner, which way do groups go? Do they go side to side or do they go up and down? Show me, which way do they go? Up and down. Excellent. Okay. So, elements are categorized into groups, and some of the groups have names. So let's take a look at the first name. Group number 1 is called the alkali. Alkali metals. Now, what do you notice about hydrogen? It's not an alkali metal, okay? Because it's a nonmetal. Group number 2 has a very similar name to group number 1, but we add a couple of letters and an extra word. They are called the alkali, but then we add 2 letters, alkaline. And then we add another word, earth. And then I did not leave enough space, so I'm going to add this on the bottom. So we have the alkaline earth metals. That's group number 2. Now groups 3 through 12, all the middle stuff, they just have one name for the whole schmear of them. They are called the transition metals. Now you might notice group 13, 14, 15, there's no arrow pointing at them, there's no box. They don't really have names. If you wanted to name them, you could name them by their top element. You could call this one the boron group, you could call this the carbon group, you could call this the nitrogen group, or you could just say group 13, 14, 15. They don't really have names. Okay, so don't worry about them. And same thing actually with oxygen. The oxygen group, group 16, doesn't really have a name. But group 17 and 18 do have names. Group 18 is known as this is the very far right of the periodic table, those are your noble gases. Okay. And then group 17, halogens. Like halo and then gens, halogens. The last 2 things that you might want to know are actually enriched, so I'm going to put black diamonds beside them. Okay. And these would be really hard to learn except for one thing. Let's go look on our periodic table and find out the name of this very first element in that row below the periodic table. Let's go look. Periodic table. What's the name? Lanthanum. Okay, I'm going to write that down back where we were. Okay, so this element right here is called lanthanum. Lanthanum. And the whole row is known as the lanthanides. Okay, so we have lanthanum. The whole row is known as the lanthanides. If you choose not to know that, it's okay. But if you want some pretty cheap and easy enriched marks, You can grab them right there. Lanthanides, because the first element in that row is lanthanum. Could you please tell me the name of the first element in that second row below the periodic table? That is actinium. So can you guess what those are called? They are called the actinides. Is this going to be what? Yes. And don't worry, we'll have lots of practice. Okay, before the time. Yes. Yes. Now, shh, hold on. We got one last little group to do here. One last little thing. We are now on page 71. I think it's 71. Yeah. Okay. So we have the tall groups. What group numbers are tall? Which ones are tall? The ones on the left and the ones on the right. So the tall groups are called the main group elements. Okay, so it's group 1, 2, and then 13, 14, 15, 16, 17, 18. Those are the main group elements. Do you remember the name of the middle section? The middle section is called the transition metals. So the short groups are the transition metals. And then finally, down at the bottom, the lanthanides and actinides are known as the inner, and again, this is going to be a black diamond, inner transition metals. Yeah, a lot of it's radioactive down there. I mean, there's some radioactive stuff up in the main body of the periodic table too when you get down into row 7 and stuff. So your homework, 61 to 71. I thought it was 74 too, but no, it's just 61 to 71. Okay? '61 to '71.